In this chapter, we're going to discuss operator overloading. Operator overloading involves extending built-in operators so that they work with the data types and classes that we create ourselves. We saw this in the last chapter with the date class, where we couldn't use the equality operator because it didn't recognize date types. So instead we had to create a equals function to compare two dates to see if they're equal. With operator overloading, we can tell the operator to recognize the types that we give to it and then have it respond appropriately. We'll start the chapter with a simple example. Let's overload the equality operator so that we can compare two date objects like we tried to do in the last chapter. So to do that, we're going to start by moving into the global area just outside our date class definition. We have to put the definitions for the overloaded operators in this global area because we cannot include them inside the class definition. If we did so, then that would require that we only provide one argument to each operator, which would be the right-hand side argument. For example, in an equality statement, you have a left-hand side value and a right-hand side value. When you put the overloaded operator definition in the class definition, then you can only provide one parameter or one argument, so that the comparisons would always be with the current object on the left-hand side and the second object on the right-hand side. We want to be able to reverse those and have either object go on either side of the operator. So to do this, we have to put those definitions in the global area where we put regular functions. So we start off by providing the return type of the operator. The equality operator returns a Boolean, so we start off with the keyword bool, followed by the keyword operator, and then the actual operator we're going to overload, which in this case is the equality operator. Then we provide the parameters, or the two objects we're going to compare for equality, which will be two date objects, date 1 and date 2. Notice that we declare them as constants and pass them as references. The constants are to ensure that we don't modify the dates, and the references are to make these operations a bit more efficient. The actual body of the operator simply involves comparing each date object's year, month, and day, or day, month, and year, however order you want to do them, to see if all three are equal. And then we will return the result of that comparison. So right here we're going to write d1.getMonth equals d2.getMonth, an AND operator, d1.getDay equals d2.getDay, AND operator, d1.getYear equals d2.getYear. We're using the getters for these objects because we're outside the class definition and month, day, and year are private, so we have to use the getters or the get accessor functions in order to make this work. And that's all we have to do for this operator, is simply make a comparison between each object's month, day, and year. If all three of these comparisons are true, then the two date objects are equal and it'll return a true value. Otherwise, it'll return false. So let's write a little code to test our operator. So we'll create a date object today and assign it a date. Then we'll create another date object, we'll call it tomorrow, and we'll assign it the date of today. Then we'll say if today equals tomorrow, cout the same day, indel, else cout the next day. Or let's not say that, let's say different day. Let's change that, because it may not be the next day. We can't say that for sure. Let's build and run the program. And it says the same day. That's good. Let's reverse the order. Compile and run again. The same day. Now let's modify tomorrow with our add day method. Add one day to that. Now build and run the program. And it says different day. That's how you overload the equality operator to work with date objects. Operator overloading is not all that complex, although there are situations where it can be. You just have to be careful about where you place the definition especially when you think you're working just with class objects. You would believe that the definition should go in the class definition, but that's not the case. It needs to go in the global area where regular, or what are called non-member functions, are placed. In the next video, we'll discuss how to overload the input and output operators, get from and put to.